So in this session, I'm going to explain you about AM transmitters. So we have in the syllabus AM transmitters and FM transmitters. And in this session, I'm going to explain you about what are the classifications in AM transmitters and what is the block diagram representation of AM transmitter. And we know that this is a block diagram of a communication system. So whether it is analog or a digital communication system, these are the main blocks included in a communication system. So to generate the information signal, which one is called modulating signal or message signal, we need a source to generate the information. We need a source to generate the information, and whatever the information that will be generated from the source, that will be in non-electrical form. So this non-electrical form should be converted to the electrical form by using an input transducer. And after that, the information signal, which is a weak signal, that is low frequency signal, it cannot travel long distances. So in order to transmit that signal into longer distances, we need to modulate that signal. And this procedure should be done in a transmitter. So we need a transmitter to do the modulation and to transmit that modulated signal. So we need a transmitter. And after that, the modulated signal will be transmitted through a medium. It may be wired or wireless medium. So that will be called a channel. And after that, this modulated signal will be received by a receiver. In receiver, we have a demodulator. This demodulator circuitry receives the modulated signal as input and extracts the original information from the modulated signal. And after that, whatever the demodulated output, that will be in electrical nature. So the demodulated output will be converted into non-electrical form by using an output transducer. So here the output transducer may be a speaker and input transducer is mic. Mic converts the voice signal into electrical signal, and at the output, the speaker converts the electrical signal into amplified voice signal. So this is the general representation of a communication system, and these are the main blocks included in a communication system. And in the transmitter, whatever the information that will be available in non-electrical form, that information you need to convert into electrical form by using a transducer. And after that, the electrical signal will be as input to the transmitter. So this is the actual representation. We need a microphone. It is a source. This will be an input transducer. This converts the non-electrical signal into electrical signal. And after that, we need a modulator, because the electrical signal, that is a low frequency signal, it cannot travel long distances. So in order to transmit the signal into longer distances, we need to do modulation. So we need a circuitry that is called modulator. Modulator is nothing but a process of changing the characteristics of the carrier signal with respect to the message signal. And we have an amplifier block, and we have a transmitting antenna here, and this transmitting antenna transmit the modulated signal through the channel, and this modulated signal is received by the receiving antenna, and after that it will be amplified, and after that it will be given as input to the demodulator. This demodulator extracts the original information from the modulated signal, so you will get the demodulated output that will be amplified by the audio amplifier, and that will be given as input to the speaker converts that electrical signal into the non-electrical form. Okay. So what are the main parts in the transmitter? In transmitter, we have a transducer and we have a modulator. Okay, so transducer is nothing but a microphone. It converts the non-electrical signal into the electrical signal, and the modulator converts the low frequency audio frequency signal into RF signal by using a carrier. Carrier means it carries the information. So it carries the information that audio frequency signal is converted to the radio frequency signal by using a modulator. Here we are doing the modulation by taking a high frequency carrier that is called RF carrier. That is also called RF carrier. So these are the main blocks included in the transmitter. And after that, this we have a power amplifier section, and that is called RF power amplifier, which is used to amplify the RF signal or modulated signal, and this will be given as input to the transmitting antenna in the final stage. So we use power amplifier in order to transmit the signal to the longer distances through the channel. So we need a power amplifier session, and we have another block that is called an antenna. Antenna converts the electrical signal into electromagnetic waves for the transmission. So what are the main blocks included in the transmitter? We have the transducer, input transducer, and a modulator and power amplifier, and we have a transmitting antenna. These are the main blocks included in the transmitter. To do modulation, for the modulator, what are the inputs? One of the input is modulating signal, and another input is high frequency carrier that will also called RF signal. It will be generated from an oscillator that is called radio frequency oscillator. It will generate the radio frequency or high frequency signal, and after that we use a power amplifier block. So what are the basic functions of transmitter? So we already discussed what are the basic functions of transmitter. Transmitter is nothing but an electronic circuitry. It transmits the information signal to longer distances. If you want to transmit that signal into longer distances, you need to do modulation. Here the modulation converts the low frequency signal into RF signal, high frequency signal, which is capable of being transmitted over long distances. Okay, so these are the basic functions of our transmitter. And we can classify these transmitters into different types, and according to the type of modulation technique we use, we can classify, and according to the type of services and for the applications, so we can classify, and according to the frequency range involved, we can classify the radio transmitters, and according to the power is used, we can classify, and according to the type of modulation technique we used, we can classify these radio transmitters into AM transmitters, FM transmitters, and according to the service used, we can classify these into broadcast AM transmitters, telephone AM transmitters, radio telephone transmitters, radio broadcast transmitters, and radio telegraph transmitters. And according to the frequency range involved, we can classify these transmitters into low frequency transmitters, high frequency, very high frequency, and depending on the frequency range, we can classify. And according to the power is used, we can classify into at low level radio transmitters and high power level radio transmitters. So these are the classifications which are based on the frequency range. So these are the frequency ranges, and these are called low frequency transmitters, medium frequency transmitters, high frequency and very high frequency, and ultra high frequency. And if the frequency is greater than 3 megahertz, these are called microwave transmitters. And depending on the type of service used, means depending on the application oriented, we can classify these transmitters into radio broadcast, radio telephony, and radio telegraph transmitters. And this is navigational transmitters and radar transmitters. And depending on the type of modulation technique we used, AM transmitters, FM transmitters, and continuous wave transmitters. In AM, we have conventional AM, DSBSC, and SSBSC. So we need a separate transmitter for the DSBSC and SSBSC signal transmission. Okay. And here I'm going to explain you about AM transmitters. Here the modulation technique will be used for the modulated signal is amplitude modulation. We know that the amplitude modulation, the amplitude of the carrier is varied with respect to the amplitude of the message signal. Here the frequency and phase will be constant, only the amplitude will be varied. So these AM transmitters we can use in radio and TV broadcasting. And here by using AM transmitter, we can transmit the AM signal. The information contained here in the form of amplitude variations. We can classify these AM transmitters into low-level modulation transmitters and high power level modulation transmitters. The small difference between the low-level modulation transmitters and high-level modulation transmitters is here the modulation will be done at low power level, means before the amplification. Here the modulation takes place, which will be far away from the antenna, transmitting antenna. And in high level modulation, the modulation takes place after the amplification. And here the high level modulation takes place at the near the transmitting antenna. So we can observe the difference between the low level AM transmitters and high level AM transmitters by using block diagram. So this is the general block diagram representation of a low level AM transmitter. So we have a modulator, low level modulator. And for this modulator, modulating signal M of T as input message signal, and the carrier will be generated from the carrier oscillator, that is also called RF signal. And after the modulation, we will get the modulated signal here, and this will be amplified by the power amplifier. So here you may observe the here modulation takes place before the power amplification. That means at the low level, here the modulation takes place, which is far away from the transmitting antenna. So this is the elaborated block diagram of the low level AM transmitter. So this is the modulator. Generally, the RF signal and AF signal both are pre-amplified by the normal amplifier sections. After that, we have to use the power amplifier. So this power amplifier it increases the signal strength or amplified the power level of the modulated signal, so that this modulated signal can travel the long distances. Okay, so this is the low level modulation AM transmitter. Here the RF signal, means carrier signal, will be generated from the RF oscillator. So here the RF oscillator frequency deviation within the, in order to maintain this frequency deviation within the limit. So the carrier frequency is equal to the transmitter frequency here. So every for every transmitter we have the transmitting frequency. So here the carrier frequency will be equal to the transmitter frequency, and after that this modulating signal will be amplified by the class A amplifier, and after that we have to use a modulator block. So here the carrier signal which will be generated from the RF oscillator, so it will not be stable output. Means if we use a crystal oscillator, we can get the stable output, stability in frequency here. Otherwise, if you use an LC oscillator, the frequency stability will be very, very low and compared to the crystal oscillator. Okay, but here in low level modulation, here the LC oscillators will be used. And the modulating signal which will be obtained from the source, and that will be amplified and then given as input to the modulator. So here before the modulation we use class A power amplifier. So class A, here the amplification should take place at low power level. So this is nothing but a low level modulation transmitter. After that we have to use a power amplifier. So it increases the power level of the modulated signal so that the modulated signal can travel long distances. So at the output, we may use a class AB or class B power amplifiers. So, and efficiency of these are also high. In order to avoid the distortion, we use class AB or class B. So when compared to the high level modulation, here the efficiency is very low because the less efficient power amplifier, because of less efficient power amplifiers which will be used in low level modulation AM transmitters. In high level modulation, in has high level modulation AM transmitters, here the signals will be modulated. So here both the carrier signal and audio frequency signal, both signals are power amplified and then given as input to the modulator. So you will get the modulated signal which will be power amplified modulated signal. After that it will be given as input to the transmitting antenna. So here the modulation takes place. Here the modulation takes place at the near the transmitting antenna. Near the transmitting antenna, and also here the modulation takes place at high power level. Means before going to the modulation, both the audio frequency signal and carrier signal will be power amplified by the power amplifiers. So here this is the block diagram of high level AM transmitter. So here we use high level modulator, and the carrier signal will be power amplified by the class C power amplifier, and AF signal will be power amplified by the class B power amplifier, and remaining blocks will be same as in low level AM transmitter, low level modulation AM transmitter. So here both the signal, carrier signal and the modulating signal, both signals will be power amplified and then given as input to the high level modulator. Means here the modulation takes place at high power level and then it given as to the transmitting antenna. So that transmitting antenna transmit the modulated signal through the channel. So these are the blocks included in high level modulation transmitters. So here we have to use a crystal oscillator to produce the stability. And also class A power amplifier we use, it will be followed by the oscillator. It acts as a buffer circuit. So buffer circuit means whatever the input we are giving, the same output we will get, and it will be used for the impedance matching. It will be used for the impedance matching. And the class C power amplifier. So here the class C power amplifier, the efficiency is very, very high, and also it raises the power level to the very high. So the RF signal will be amplified by this class C power amplifier, so that the power level of the carrier will be very, very high. And audio frequency signal, which will be processed by the audio frequency unit, and this that is a simply class A amplifier. Class A amplifier. So what is the main difference between the low level modulation AM transmitters and high level modulation AM transmitters is that the power amplification. So here in low level, the power amplification takes place after the modulation, and in high level modulation transmitters, the power amplification should take place before going to the modulation. So both the RF signal and the audio frequency signals are power amplified. And also in high level modulation, high power class C power amplifier will be used, so that the RF signal power will be very, very high. So these are the differences between the low level and high level AM modulation transmitters. So you may observe these are the differences. So here the modulation is carried at low power level, and here the modulation takes place at high power level. And here the amplifier uses less amplifier stages, and it also uses more amplifier stages. And the efficiency when compared to the high level modulation, this has power efficiency is very low, and this has power efficiency is very high. And the power losses. So in power amplifiers, we have the power losses are high. So in a low level modulation, the main drawback is the cooling problem. So here the cooling problem is not severe. And also applications. So it can be used for the high power broadcast transmitters, and it is used in TV transmitters. So these are the differences between the low level modulation AM transmitter and high level modulation AM transmitters. So AM transmitters basically classified into two types. One is low level and another one is high level. And depending on the type of modulation technique we used, we can classify the transmitters into low level AM transmitters and amplitude modulation transmitters and frequency modulation transmitters. In AM transmitters, the type of technique we used is the amplitude modulation, so that AM transmitter can send only the amplitude modulated signals. Okay, so this is all about AM transmitters. So in transmitter section, what are the main blocks we have? We need a source to generate the information, and after that we need a transducer to convert that information into electrical form. In transmitter, what are the main blocks are a modulator and a amplifier block, and we have a transmitting antenna also. Modulator modulate or changes the characteristics of the carrier signal in order with respect to the message signal. For the modulator, we have two inputs. One is the information and another one is the RF signal, RF carrier signal. So carrier signal, it will be generated from an oscillator. So that oscillator produces very high frequency signal, that is called RF signal. This RF signal carries the information. So output also called RF signal, that is called modulated signal. And after that modulation, we have to use a power amplifier session. In order to transmit the signal into longer distances, we need to amplify that modulated signal, and that will be given to the transmitting antenna. So transmitting antenna transmits the modulated signal to the channel. What we call it as a medium. Okay, so this is all about a low level AM transmitter and high level AM transmitters. In next class, I will explain you about FM transmitters.